Hey everybody, hope you're doing okay today. This is going to be a little warm-up that'll help you get ready for lesson 1, and it'll help you do some of the questions I'm going to put on the McGraw-Hill site today. There were a ton of examples in the books, and instead of doing a ton of examples, I decided just to do this little sheet right here, which will kind of give you a good introduction to the questions. So lesson 1 in chapter 4 is all about representing relationships and the different ways you can do it. In class yesterday, we showed how you can do it with a graph. Remember the graph about the space shuttle? We showed how you could use the table. We wrote it out in words. Remember, it was going 5 miles each minute. We even made an equation or an expression to represent the situation, and that's what we're going to do again today. We're going to represent these relationships between the number of weeks and the number of hours, the number of months and the number of houses, whatever it is. We're going to represent those relationships different ways, and that's all it's going to ask us to do. It's really not that bad. So I hope today should be an easy, pretty not very stressful day for you. So here's number 1. I'm sorry, I left my phone holder at home, so I'm just holding it here with my hand. So if it's a little wobbly, I apologize. Number 1, a fitness instructor exercises about 15 hours per week. 15 hours per week, right? So they ask us to write an equation to find the total number of hours, H, that the instructor exercises in any number of weeks, W. So we have a relationship here between the number of hours and the number of weeks. If you look, you should see a pattern here, right? The weeks are counting by 1. Pretty easy to tell, right? 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. Those are counting by 1. What are the hours counting by? From 15 to 30. If you know that in your head, great. That's adding 15, right? If you didn't know that in your head, you could use a calculator. Do 30 minus 15. What about from 30 to 45? Is that also plus 15? What about from 45 to 60? That's also plus 15, right? Isn't it? So it's safe to say that the hours are going up by 15, the weeks are going up by 1. This is 15 hours per week, just like they said in the question. So what that means is, in order to get from here to here, they've multiplied it by 15 every time, right? Does 1 times 15 equal 15? Does 2 times 15 equal 30? Does 3 times 15 equal 45? Does 4 times 15 equal 60? I think it does, right? You could check it with your phone or with your calculator. But all of those, if you multiply them by 15, right, 15 over 1, 15 over 1 is 15, and that's what you multiplied it by to get your answer. So my equation, notice an equation here, has to have an equal sign. I'm going to do the number of weeks times 15 equals the number of hours. They have your abbreviations right here, right? Don't make up your own. They'll tell you what to use. Equals the number of hours. Now, if you think that's backwards and we'd rather flip it around, I'm okay if you would rather write it like this, right? 15 times W, and put the H equals at the beginning instead of H equals at the end. This is probably the more common way, but you could do it this way too. They're both fine. And now that I have my formula, can you tell me any number of weeks? Of course you could, right? If I said, what about 10 weeks? Could you do 10 times 15? If I said 300 weeks, could you do 300 times 15? Of course you could. That's what you're asking, or that's what it's asking you to do. Just use the equation to determine the number for 9 weeks. So instead of making this table go all the way to 9, I'm just going to put the number 9 right here into the formula. I'm just going to do 15 times 9, or 9 times 15, and figure out how many hours it would be for 15 times 9. Now, I don't have a calculator with me, so I'm going to have to do it by hand, but if I had my calculator on my phone or just a calculator at my house, that would obviously be a little bit faster. 135 hours. So there you go, right? That's all we're going to do today. Look at the chart, find the pattern. Like, this one's kind of easy. Like, some of you might have been able to get, oh, it's times 15, it's times 15, it's times 15. But if you're not able to get it in your head, you might have to look for the pattern going up and down like this. All right, let's do another one just to kind of show you what I mean. A real estate company sells 8 houses per month. Now, if you think you're smart enough to write the formula right now, go ahead. But for a lot of people, you might need to just kind of look over here, right? What are the months counting by? 1, 2, 3, 4. Those are obviously counting by 1 every time. So the months are going by 1, and that's pretty typical. This one usually goes by 1. What are the houses going by? From 8 to 16, from 16 to 24, from 24 to 32. How much is that adding every time? It's adding 8, isn't it? 16 plus 8, 24 plus 8. So it is going by 8. So our slope is 8 over 1. 8 over 1. And so what I could also say is, from here to here, we're multiplying by 8, aren't we? 1 times 8 equals 8. 2 times 8 equals 16. 3 times 8 equals 24. 4 times 8 equals 32. This looks really confusing, but it's really not that bad. Just, it's multiplying by 8 every time, isn't it? So I'm taking the number of months times 8, and that's going to equal this number, the number of houses. Equal sign, you have to have an equal sign. If they say equation, you've got to have an equal sign in there. M times 8 equals H. Or if that looks backwards to you, you could do this. And you really don't have to put the dot in there. You could just put 8M, but I like to put the dot just to remind me it's multiplying. Okay, there you go. Now that I have the formula, I can use that equation to figure out any number of months. And look, they asked for 15. So if I continue this pattern all the way down to 15, where would my answer be? Well, instead of having to do the pattern all over again, let's just do 8 times 15, or 15 times 8. It's the same thing. 15 times 8, how many is that? I've got a calculator. This would be faster, but I don't because I'm holding my phone right now. So I'm just going to use this, 120.
Mr. Coslick, call the office, please. Mr. Coslick, call the office.
Sorry about that, 120 houses. Okay, so if they give you a table, that's all you have to do. Look for the pattern. If you're having a hard time, some of you will just be able to know right off the bat. Boom, it's times 15, or here, it's times 8, times 8, times 8, times 8. But if you're not the best at just looking at it and being able to tell that it's times 8, you can do what I did over here to just really make sure that you know. Now, what if they switch it up? And instead of a table, right, these are tables. Instead of a table, what if they give you a graph? Like this is obviously a graph. Don't let that bother you. It's the same information. Isn't this 1, 2, 3, 4 the same thing as this? 1, 2, 3, 4. Yeah. And aren't these numbers kind of the same? Now, I know they're not the same numbers, but isn't kind of the same format, right? This information is the same thing as this information. Well, it's not the same information, but it's kind of a different way of doing the same thing, right? Could I have taken all these points and made my own little table for them, right? Could I do 1, 2, 3, 4? Sorry about that. I had to kind of move the phone down. And then could I do like 35, 70? Man, I'm going to have to put my arm over here. It's really hard to hold the paper down. 35, 70, 105, and 140. I'm sorry. Got to zoom in on the paper there. See, I could make a table out of this if I really wanted to, but I don't really feel like I need to. Months and money, right? You should be able to kind of do the same thing we did on the table whenever they give you a graph, right? The graph shows the amount of money the Zimmerman family spends on movies each month. Okay, write an equation to find the total amount of money, C, spent on movies in any number of months, M. Okay, we have to figure out how much money do they spend each month. Okay, let's look at these first. 1, 2, 3, 4, right? Or if I wrote it like here, they're going by 1, right? The months are going by 1. What is the amount of money going by? Here I wrote over it. It's kind of hard to tell. 35, 70, 105, and 140. What is that counting by every time? From 35 to 70, what's that counting by? From 70 to 105, from 105 to 40. If you don't know it in your head, that's okay. A lot of people don't know that in their head. You can use your calculator and just subtract them, right? You could do 70 minus 35. Then you could do this one minus this one. 105 minus 70. You could do 140 minus 105. And if you do all of these, you'll find out that it was going by the same amount every month. It's going by $35 there. It's going by, man, I'm having a hard time holding my paper, keeps wanting to move. 35 right there. It's going by 35 right there. It's going by 35 every time, adding 35 every month, right? So what that means is this is really multiplying by 35, right? 35 times 1, 35 times 2 equals that. 35 times 3 equals that. 35 times 4 equals that. It was counting by $35 every month. So what that means is we're going to do the number of months times 35, and that'll give us the, don't put a dollar sign, put the letter C that they gave us. That's going to give us the cost, $35 every month. And if you think that looks weird and you want to do it the opposite way, you could write it like this as well, right? Both, you don't have to do both, but just pick one. The number of months, each month times 35 will give you the dollar amount. So now what about if we had 1 year? Whoa, they tricked us. This is months, this is year. What should I put in to represent a year? How many months is a year? Right, that's 12, isn't it? So I'm going to do 12 times 35. And once again, a calculator would be great. I think I know it, but I'm just going to double check. Ran out of space. $420 is what that is. $420 should be what you get when you do 35 times 12. Okay, so even though they did this one with a graph instead of doing it with a table, I was still able to do the same thing, right? I was still able to count and see that this is going by 1. I was still able to count. I use subtraction because I'm not the best at doing this in my head. I did 70 minus 35. I did 105 minus 70. I did 140. These were counting by 35 as well. And so I was doing 35 every month. Okay, one more of these and then I promise I'm done. This video will be about 15 minutes and then we'll stop. This graph over here shows the total cost of hats that are for sale at Hats Bonanza. That's a funny name. Okay, so 1 hat cost $8, 2 hats cost $16, 3 hats cost $24, 4 hats cost $32. If you're a baller, you know what they're multiplying by, right? Boom, 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 boom. 1 times something equals 8. 2 times something equals 16. 3 times something equals 24. And 4 times something equals 32. Right? I know what that is in my head, but maybe you don't. If you're not the best and you want to make a little table for yourself off to the side, you can see that the first number in each parentheses, 1, 2, 3, 4, and, sorry about that, the second number in each parentheses goes 8, 16, 24, 32. And so you can see these are counting by 1, right? Adding by 1. If I wanted to draw my little arrow, I could and do the plus 1, plus 1, plus 1 every time. Over here, from 8 to 16, from 16 to 24, from 24 to 32, right? These are counting by 8 every time. Plus 8, plus 8. And you might have even just known 1 times 8 equals 8, 2 times 8 equals 16, 3 times 8 equals 24, 4 times 8 equals 32. So each hat costs $8. So the cost is going to be the number of hats times 8 equals the cost. Or if you think that looks weird and you want to go the other way, 8 times H. You really don't even need the dot in there. You could put C equals 8H. That would be fine. Either one of these is fine. $8 times the number of hats. So now it says, what about if 30 hats? Now this graph doesn't go all the way to 30, but if this graph went all the way out to 30, how high up would the dot be? Like it'd be way out here somewhere, right? If this went all the way to 30, I'd have to go way up here somewhere to find the dot. So instead of doing the graph all the way to 30, because that's going to take way too much space, let's just put 30 right here and do 30 times 8. $30 times 8. 30 hats and they're each $8. 8 times 3 is 24. That's going to be $240 for 30 hats. Okay, that's all you got to do today, guys. So I hope you enjoyed watching this. Hopefully you were able to figure it out. And if you're still really confused, you can ask me for some help. I'm going to put some questions on the McGraw-Hill site. I hope you remember how to get there. We were there all the time in November and December, right? I'm going to put some easier ones like this. They should all be multiple choice where you don't have to like type your answer or write in. Like I had to write in the equations. They'll probably give you a list and you can just choose the one that makes sense. And let me know if you have any problems. Try to get this done by tomorrow so that you can be prepared, because tomorrow we'll pick up where we left off here, and I'll probably give you another chance to practice some of these on your own tomorrow. So go to the McGraw-Hill site, and I should have an assignment on there called 4.1, Representing Relationships, and give it your best shot today, guys. All right, have a good one. I'll see you tomorrow.